Hey kids, welcome back to some more science, 'cause science is cool. We are going to start a new unit about some special kinds of machines. We have 6 different special kinds of machines to talk about, and they're called simple machines. So what does it mean to be a simple machine? Well, let's talk about machines in general. What is a machine? Is a car a machine? Yes. Is a dog a machine? No. Is a vacuum a machine? Yes. How about a tree? I have a riddle for you later, like when is a tree a machine? But in this case, no, a tree is not a machine. So to sum it up, these items are machines because they have moving parts that have been fit together to help us do work and to move things. These things are alive things. I'm going to show you a very special kind of machine, and you're going to say, "What? Teacher Wendy, how is that a machine?" Ta-da! Remember I said a tree can sometimes be a machine? Well, this is a piece of wood, which does come from a tree, and it is a machine, a simple machine. It's called a lever arm. Well, not necessarily like this. I'm going to show you how it can be a machine. There are 6 kinds of simple machines. A simple machine is a machine that doesn't have any moving parts, right? If you open up a vacuum, there's gears in there and springs and all sorts of things in there. And you've seen the inside of a car engine. There's lots and lots of parts. This doesn't have any parts. It's just of wood. And I have screwed this on the back to help me make it into a teeter-totter, which is how I'm going to use it to do some work.
Suppose you wanted to move a large stone, but it was too heavy. One simple machine that could help is the lever. A lever can be any bar that tips back and forth on a point. The point is called the fulcrum. When you exert a force on one end of the lever, it produces another force here on the other end to lift a load.
Here's my fulcrum, my pivot point. If I put it in the middle, let's take this big, heavy, safety first. I'm going to take this big 5-pound weight and put it on one end. And of course, it clunks right down because this is heavy now and this is not. If I take 2 of these is the same as one of those. And as long as my fulcrum is kind of in the middle of the board, and the board weighs the same, they balance pretty easily. Right? Teeter-totter, teeter-totter, but it's not, I don't have to do much to hold it up. Okay, I can't quite get it exactly balanced because these are floppy, but if I could, you would see that 2 of these is one of those. Now, I'm going to take these off. What happens if I make my lever arm right now is the distance from the rotating part out, so it's this long. What if I make that shorter? I'm going to move my pivot point way over here. Now I'm going to put 2 weights on there. Nothing happens. This lever arm is really short, and even though it still has the same amount of weight before, when they balanced, it won't balance anymore. In fact, even if I push on this, oof, what if I pile some more on there? I'm just going to put a bunch of weights on there. Nope, still not enough. I can help it with my muscles, but this lever arm from here to here is too short to lift up that big weight. What if I move the pivot point the other way? All right, take these guys off. Off you go. Now, I'm going to take and I'm going to move the pivot point way over here. So my lever arm is really long now. Still have my little weight on there. Ooh. That doesn't seem very heavy. Let's find out how much weight we need for that. Let's put one of these little guys on there. If I get it to just right, wow, I can actually get it to balance right about there. Even though this is 2 pounds and that's 5 pounds, that's twice as much weight. It can do the job. I wonder if I can get one of these little guys to do it. Where would I need to move that arm? Let's take a look. Mostly to the end, I think. Ah, look at, even this little tiny weight can pick up this great big weight with a long enough lever arm. So that's the idea of the lever arm. Let's talk about when you use lever arms, or people in your world use lever arms, because we use them all the time, knowing this: the longer the arm, the less work I have to do. That's a tool. Let's talk about some tools. You all know what this is. It's a hammer. So if I have a nail and I want to put it into the wood, I need a way to bang it in there, because wood is hard. Now, I can try to press it with my thumb, but that doesn't really work, does it? I'm going to try to put it in with a hammer. There's different ways to hold a hammer to get different amounts of muscles. If I hold it near the top like this, safety first, it doesn't give me very much muscles because I not have much of a lever arm. If I move my hand out, now I'm using this whole lever arm all the way out to here. Bam, bam, bam. Wow, that really went in, huh? That does a better job than trying to hold it here. So if you ever want to nail something in, you want to hold the hammer by the bottom. Now, a hammer is a very special kind of lever arm, because not only can you put things in, you can take things out. If I want to get this nail out, I don't have the strength to do it. Ugh. But, do you ever notice this thing on the hammer? The claw. The claw helps you get the nail out using a lever arm principle. Watch this. I put the hammer like this. Here's the pivot point. Here's my handle, and I just have to rotate 1, 2, and it pulls it right out. I did give it a little jerk because it was in there pretty hard, but I couldn't do that with my hands, could I? Thank you, hammer, for being a great lever arm. For those super big jobs, things that are really hard to get in, I can use this tool, which is also another example of a lever arm. It's called a crowbar. I can use this to open up things that are nailed shut, or stuck doors, or even, look at how long this lever arm is. It's longer than my other one. If I have a nail that's really stuck in there, I can use my crowbar. Whoop! Oh, that just did it really quick, didn't it? I had a bigger arm. When I tried to pull that out with my hammer, I had to jerk it twice. But with the crowbar, I only had to do it once. It gave me more muscles by being longer from that pivot point. A lot longer. Cool. Here's a kind of lever arm that you've seen before. It actually has 2 lever arms crossed together at the middle. Here's one, here's the other, and the pivot point is right in the middle. This is an awesome lever arm, used, of course, for cutting paper. Ta-da! But this kind of system isn't very good for cutting a stick, is it? And it's not because the blades aren't sharp. They are. They cut the paper just fine. It's because these lever arms are too short to do the job. Let's see if we can find something that can do the job. How about this guy, huh? This is a hedge clipper, used to trim out branches, tiny branches on trees and hedges. It's pretty big, isn't it? The lever arms are bigger than the scissors. It also has a pivot point in the middle. I wonder if this will cut this. Nope, I need longer lever arms. Ugh. So this one is longer than the scissors, but what about this one? This is an actual branch cutter, and you can see it's a little goofy looking. The scissor part, the cutter is really tiny, but the lever arm is really big. When I open these great big ones, the little one doesn't move quite as far, but I can get a lot more muscle in there because of these long, long lever arms. Let's see if we can cut this stick now. It's a little awkward for me to hold this. Let's see. Oh, that cut it so easy. Whew, I didn't even sweat on that one. That did a great job helping me with these great big lever arms. Snip, snip. So lever arms can get pretty complicated. How about this thing? look at this contraption. What is it? It's a catapult. So on this invention, which I didn't invent by the way, I just made one, here's the lever arm right here. Here's the pivot point, and you can see the other side of the pivot point is very small. It's not like my teeter-totter where the pivot point's in the middle. Here the pivot point's at the end. That's going to allow this to go really fast. I've got a cup on the end and a rubber band to help me. You want to watch it go? I'm going to use this lever arm with this rubber band to shoot this little cotton ball zip over that way. So when I pull down, the rubber band gets tight, and then ready, oh, safety first, ready, set, go! Oh, sorry. That's another fun use for a lever arm, right? Here's another little catapult I made using popsicle sticks. Kind of the same idea as the other one, where it has the fulcrum at one end to allow the lever arm to be pretty long, which is going to give me some really good force. I'm going to be able to shoot this guy all the way over there. Safety first. Ready? Boing! Whoa! That went all the way across the room. Try it again. Here we go. Boing! Woo! That hit the wall too. Cool. For my last experiment, I am going to lift up this couch with my foot. Yes, you heard me right. My foot is going to lift up a couch. Now, this couch is pretty heavy. I can lift it, but it's super hard. I have to use both hands and my muscles. So how am I going to lift it with just my foot? My foot, I can't do that. Nope, nope. I'm going to have to use some science on this. Science with simple machines. I have here another pivot system, a fulcrum, the pivot that I'm going to place right there. And then I have this great big teeter-totter thing that I am going to put under there. Just like that. Now you can see where this is going, right? Here's the pivot point. If I step with my foot on this lever arm, it's going to make that end go down and that go up. And I have to put my fulcrum in the right spot. If I put it way over here, it's not working. I can stand on it. I need more force, more muscles. So I'm going to need a longer lever arm. Here's the lever arm when the pivot point's here, but what if I move my pivot point over there? Ready? Safety first. Ta-da! Go science! Science is cool! Well, that's the end of this lesson. I sure hope you enjoyed learning about the lever arm. It's a pretty cool machine. Don't you think so? Science is